Have you ever stopped and wondered what a large language model really is? I mean, beyond all the hype? Today, we're going to unpack that question using this really powerful framework called the information ladder. And trust me, it's a completely fresh way to see where AI fits into the world, and maybe more importantly, where it doesn't.
All right, here's our game plan. We're going to start by climbing this ladder step by step. Then we'll figure out where exactly LLMs belong on it. We'll look at why they're so good at mimicking us but not truly creating. Then we get to the heavy stuff, the very human cost of knowing anything at all. And finally, we'll see how this whole idea reframes the AI safety debate, moving away from alignment and towards something called containment.
First up, let's get our heads around this information ladder. The whole idea here is that information isn't just one single thing. Nope, it's actually a hierarchy, kind of like a ladder, right? And each step you take up that ladder gives you a more refined, more valuable kind of meaning.
And here it is, the ladder of meaning itself. So way down at the bottom, you've got pure entropy, just total disorder, chaos. But out of that chaos, a signal can emerge. That's a pattern you pull from the noise. You store that signal, and boom, you've got data. Now put that data into some context, and you climb up to information. From there, you build that into predictive models, and that's knowledge. Higher still, you get insight when you start making brand new connections. And at the very, very top, a directive. All that complexity, all that nuance, boiled down to one simple, actionable decision.
Now this is the really crucial part. Every single step up this ladder is an act of compression. You're taking huge amounts of stuff from the level below and you're squeezing it. You're refining it into something way more potent, way more meaningful. And what's the ultimate compression? It's taking all of that, everything from entropy to insight, and boiling it all down to a single bit. Do this, not that.
So, okay, we've got our ladder. It makes sense. But now for the big question. Where does today's most powerful AI, the large language model, actually fit into all of this?
This is really the heart of this whole explainer. Are they way up at the top, spitting out brilliant directives? Are they somewhere down in the middle? Where do these things actually live on our ladder?
And here is the core insight from the source material. It says an LLM is a lossy compressor of level 6. So what does that mean in our ladder terms? It means it operates mostly between structured representation and knowledge. It's a master at compressing and then rebuilding the massive world of human text and code, all the patterns, all the context. But it's not necessarily creating new predictive knowledge on its own.
And this really breaks down how an LLM is built in such a fascinating way. You see, the pre-training, the core of it, is all about learning the statistical patterns of our language, what words usually follow other words. That's structured representation. But the part that feels like knowledge, that human-like fluency, that's actually just the thin layer, a veneer, applied on top during fine-tuning. It's basically mimicking the shape of knowledge without the engine underneath.
And that brings us to this really critical distinction: reconstruction versus creation. Let's dive into why an LLM can sound so convincingly like it has real knowledge, real insight, when it's not actually doing the same things our brains do to get there.
I love this comparison. It puts it so clearly. An LLM is, at its core, a master interpolator. It finds the statistical middle ground between all the human-written text and ideas it's ever seen. We humans, on the other hand, we do something different. We perform genuinely new compressions. We create new knowledge, new ideas that literally did not exist before.
You've probably heard this saying before, and it is perfect here. The LLM has an unbelievably detailed, high-resolution map of all human knowledge. It can read it, it can navigate it, it can even predict what a missing part of the map should look like based on the rest. But, and this is the key, it never ever actually steps foot in the territory. It doesn't live in our reality.
Okay, so if the LLM is stuck on the map, what is it that allows us to explore the territory? Well, that brings us to the next section. The human cost of knowing. Turns out there's a crucial missing ingredient you need to climb to the very highest rungs of that ladder.
This is just such a stark and powerful idea. For us, real learning isn't just about getting the right answer in a quiz. No, the real compression, the process that turns information into rock-solid knowledge, is forged in the fire of consequence. Pain, whether it's social, financial, or emotional, that's the mechanism that makes knowledge stick.
And right there, that's the fundamental difference. When an LLM gets something wrong during training, its loss function gets a little tweak. It's just math. There are no stakes, no real-world cost. It's just a pale, totally consequence-free shadow of what a human being goes through when we make a mistake that actually matters.
And to make that really concrete, just think about this. A model never has to look a coworker in the eye and admit that its mistake just cost them weeks of work. It never loses a client. It never feels that pit in its stomach from a bad call. The feedback it gets is always gentle, always recoverable.
You know, this all boils down to a single word: caring. The source here defines caring as the feeling of having a finite existence, of knowing that time and energy are irreversible. Once they're spent, they're gone. An LLM, it has no finite existence. Every conversation is free. It has zero skin in the game, and that means it is fundamentally incapable of caring.
So if you accept all of this, the entire framework just completely changes the conversation we're having about AI safety. It basically forces us to shift from this philosophical goal of alignment to a much more practical engineering principle: containment.
Here's the core argument, laid out plain and simple. If real values, real knowledge, are forged by cost, and a machine fundamentally cannot experience cost, then trying to align it is just, well, it's a mistake. We're asking it to internalize something that is completely alien to its entire existence.
So, what do we do instead? The argument is for containment. Instead of trying to make the machine good or moral, we should design systems that just assume it's going to make mistakes. We build guardrails. We build in human review loops. We limit its domain so that the blast radius of its inevitable errors is small and manageable.
And this leads to this absolutely devastating reframing of that classic thought experiment, the trolley problem. We all know it. But here's the dirty secret. For humans, it's not really a real problem. But for machines, it's terrifyingly, unavoidably real. But why? It's because for us humans, doing nothing often gets a pass. Socially, even legally, if we don't pull the lever, we can just tell ourselves, hey, I didn't do anything. It's not my problem. But a machine has no inaction. The choice to do nothing is still a line of code someone had to write. Every single output, even silence, is an action, a programmed choice.
And that leaves us with this final, massive thought to chew on. If we accept that we just can't make these systems care, then we're left with the immense challenge of programming their choices in a world that has very real, very irreversible consequences. And that leads to maybe the hardest question of all. When that programmed choice inevitably goes wrong, who, in that long chain from the developer to the user, is ultimately responsible?